Okay, so taking a look at the properties of tan, the property of tan is that it repeats itself every pi radian. So we have a period of pi. So our middle is going to be at 0 here, and it's going to go half a pi to the right, half a pi to the left, so the period is pi. The asymptotes are at pi over 2, 3 pi over 2, and they repeat every pi radian. So 3 pi over 2, the next one will be 5 pi over 2, and we can go with the other direction as well. We also have zeros. The zeros are happening at 0, and then the next one's at pi, 2 pi, etc. And those zeros is really important that we understand the zero. That 0 is our main reference point. Okay, so that's the middle of the graph, and that's where all our symmetry happens, is from that 0. Now, we could also look at tan as sine over cos, because if we think of the slope ratio, that slope ratio is going to be rise over run in the unit circle is going to be the length sine over the length cos, and that gives us the same as the y over x. So these are the main properties of tan. When we look at the graph of tan, it looks like this. We have our one quadrant here. Okay, that's one quadrant, and then we have the other quadrant going in the other direction and the negative direction going that way. And it is symmetrical, so each quadrant is symmetrical. The period again is pi, we can see that. The asymptotes are at negative 2 pi over 2, 2 pi over 2. The next asymptote will be at 3 pi over 2. Okay, so that point being pi. And then we'd have another graph that's repetition of that original graph that goes through there, and it is symmetrical like that. And then we'd have another point here, we'd have another 0 here, and again, it's following that same pattern going in the other direction. Okay, so our main reference point is going to be that point there. That's our center. That's what we're going to keep track of when we do our transformations. Now, there is another point that is very useful to keep track of transformations, and this is especially in terms of a vertical expansion, because that point there we cannot vertically expand. So there is a point that we can use to keep track of vertical expansions. So at pi over 4 or 45 degrees, let me just rewrite that because it's hard to see. Okay, so at 45 degrees, or pi over 4, we know that the slope is 1. So we go 1 pi over 4 over, the y value is going to be 1. If we go in the negative direction, negative pi over 4, the slope is going to be negative 1. So that slope value there is going to be at negative 1. So that's another reference that we can use. Okay, so I'm just going to write that coordinate in. That becomes a very useful reference point because that can allow us to then show vertical expansions, which that center cannot. And this point here is going to be at negative pi over 4 and negative 1. Okay, so that when we draw one period, we're going to draw this in, and if we need to show vertical expansion, we can use that point that's halfway between the center and the asymptote, which is at 45 degrees or pi over 4.